Open vocabulary segmentation aims at segmenting images into a set of categories expressed through free-form text. Training-free OVS methods can be broadly categorized into two types. The first type explores the attention mechanisms of pre-trained models to perform OVS. They modify the internal mechanisms of vision language models such as CLIP or generative models such as diffusion models to improve their localization capabilities. However, attention-based approaches are constrained by the inherent limitations of the models they rely on, resulting in low-quality masks and noisy label assignments. The second performs OVS by referring to a constructed reference set. They generate class-agnostic masks, then retrieve and aggregate their labels according to the reference information. They can possibly produce higher-quality masks with less noisy labels, but the performance remains unsatisfactory. We believe retrieval-based approaches have higher potential by correcting VLM vulnerabilities through reference substances. But the fundamental data quality issues are heavily overlooked in existing solutions. In our preliminary study, we investigate the impact of data quality by viewing the ground truth Cocoa Stuff annotations as a high-quality reference set, and compare VS performance between retrieving from this ground truth set and S-Clip, a representative attention-based method. Despite a simple retrieval strategy, we observe a consistent performance improvement. This indicates the significant potential of data for enhancing training-free OVS. However, when we compare S-Clip with FRIDA, a well-performed retrieval-based method using synthetic images to produce a reference set, their performance remains comparable. The potential of data for retrieval-based EVS remains locked. Retrieval from ground truth annotations significantly outperforms the synthetic reference set, confirming that data quality is crucial. The challenge is, without relying on manual ground truth annotations, how to curate such a high-quality, densely annotated dataset. In this paper, we introduce ReME, a data-centric framework for training-free OVS. ReME includes two phases: a data pipeline that constructs a high-quality reference set, followed by a simple similarity-based retrieval phase that assigns pixel-level semantics to test images through retrieval. Our data pipeline aims at constructing a well-aligned, rich, and contextually relevant reference set with segment text embeddings. It starts from the initial pairing phase, where we use images as input, extract class-agnostic segment masks, and pair noun phrases extracted from image descriptions with them, to obtain a diverse set of segment text pairs. The data-enhancing phase is designed to address the inherent quality issues in the base set. In the first module of group-based filtering, we leverage the aggregation effect to group segments labeled with the same semantics and perform outlier filtering according to similarities between segment features in the same visual modality. After mitigating segment text misalignments, we utilize the global semantic richness within our base set to identify semantically similar concepts and enrich the textual modality of our reference set. Our data pipeline produces an enhanced set with high-quality segment text pairs. By encoding image segments, textual labels, and their pairings, we construct the reference set for OVS. Now we delve into our similarity-based retrieval phase. To reflect the fundamental capabilities of data quality, we deploy a simple similarity-based retrieval process without heavy computational overhead. After obtaining embeddings of class-agnostic segment masks and test classes, their affinity metrics between segments and labels in the reference set are computed, to be aggregated as the final prediction. By retrieving from our constructed reference set, which only uses Cocoa image as input, our results even surpass retrieval from ground truth segment text data. Extensive experiments show that ReME consistently outperforms existing training-free methods across 10 benchmark datasets. Beyond quantitative evaluation, qualitative results further demonstrate ReME's capability of producing high-quality results. In conclusion, we introduce a novel training-free OVS framework focused on quality-driven data refinement. Our scalable data pipeline generates high-quality segment text embeddings without human annotations. Using a simple retrieval strategy, our approach outperforms all existing training-free baselines across 10 benchmark datasets.